Hi, everyone. It's Dr. Robyn MacKillop with Get That GED, and today we're going to work on surface area of various shapes, pyramids, cones, cylinders, rectangular prisms, which is basically a box, triangular prisms, which is basically a 3D triangle, and I think there's another one. I don't think we'll get to composite shapes where you have several shapes in one today, but we will definitely get to it because that's likely what you're going to see. All right, I'm going to switch my camera. Aha, pyramids. Pyramids up first. Let me clear this. That looks terrible. And again, you'll absolutely want your formula sheet. Let me pin this. There we go. So we'll be doing these and some of these. Volume is not bad. You just have to remember that big B, and we'll get to it when we do right prisms and pyramids. Let's not start with pyramids. Let's start with something else because there's plenty. We'll come back to the pyramids. There's some composites. Oh, upside down. All these are upside down. All right, we'll start with the easy. Boxes are the easiest for anything. They just are. So we'll begin here. We're going to do surface area and volume. So surface area, let's look at this shape. If you were going to paint this, that's the surface area. You'd be measuring everything on the outside. When you measure volume, you're measuring how much it'll hold. So if it were a vase, a square vase or rectangular vase, the volume would be how much water you could put into it, how much sand, whatever you wanted to fill it with, marbles. Usually you count marbles, but you could do them by volume. So surface area outside, volume inside, what it'll hold. So let's take a look at the formula. It looks long, it's not. Let me rephrase that. It looks complicated, it's not. It is long. It looks long, it is long. So you've got 2 length times width plus 2 length times height plus 2 width times height. I'm going to write that down. 2 length times width plus 2 length times height plus 2 width times height. All right. So we're just going to fill this in. We've got a 1, a 3, and a 1. And it doesn't really matter. You can label them if you want. It doesn't matter where you start. Let's say length is the 3. Let's say height is, it doesn't matter what order, because you're going to cover all of them. So we've got 2 times 3 for length times width is 1 plus 2 times the length again times the height, also 1, plus, and I'm going to have to carry this down because I did not do a good job giving myself enough room. Width is 1, height is 1. Your calculator will do all of this on its own. And where is my calculator? Oh no, I need my calculator. Here it is, or here's one. This will do. So we've got, let me move this over so you can all see it. So we're going to have 2 times 3 times 1 plus 2 times 3 times 1 plus 2 times 1 times 1. So long but doable. 14. So the surface area of this particular little box is 14 square centimeters. Now, you are not going to have to worry about that on the test. This will be done for you. So don't worry about centimeters, inches, squared, whatever. Now let's do volume for a box. So going back to our formula sheet, volume is length times width times height. So this one was surface area. And then volume is just length times width times height. So that's going to be 3 times 1 is 3 times 1 is 3. That's going to be 3. So volume, especially for boxes in and of themselves are not bad. And so I'm not going to do a whole bunch of them. We'll just do this one. But for any of them, you're just punching in numbers into the formula. So even though this is a particularly long formula, it's not a complicated formula. And if you can get it set up in your calculator, because you can use the parentheses, super easy. You just type that all in, hit enter, and you're good to go. All right, let's take a look at what's next. We've got cones. So surface area and volume of a cone. Right here, pi times r radius times side, that's what the S is, plus pi r squared. So I'm going to write that down. Got pi times radius times side plus pi r squared. So that's the full formula. For these, you're going to need the full formula. Excuse me. What's interesting is they're assuming this is a solid. The base is solid. So the whole thing is solid. That's why they have this piece. This is measuring the surface area of the base or the circle at the bottom. This is measuring the surface area of the cone itself. So if they gave you a problem on the GED test and they were saying you need to measure like a snow cone cup. So remember the paper cups that snow cones came in? That doesn't look great, but you get the idea. A snow cone cup is open. The round part is not solid. So for a snow cone cup, you wouldn't be measuring the solid round. So you'd get rid of that part of the formula. You would just use this to measure a snow cone cup. Does that make sense, hopefully? This is only the base, the round base. If it's solid, you have to use both. If not, you eliminate this. Boy, that doesn't look like round, does it? Round base. I'm writing way too little. All right, let's try this one whole thing because the bottom is solid. So we've got pi, which is always 3.14, times the radius. And they gave us the radius, not the diameter, so that's even easier, times 16. Okay, here's where this gets sketchy. We need the side. So the angled part, that's the side. They gave us the height. We have to do another step. We have to use the Pythagorean theorem to get the side. So another issue, or well, not an issue, but another step. This is why it's hard to go really, really, really fast on the test because they give you several problems in one. So here we got to go back to Pythagorean theorem. A2 plus B2 equals C2. We know A is 32. And we need to square that. Plus the bottom, the base, 16, square that, equals c squared. All right, I need my calculator because I could not do that in my head if I wanted to. So 32 squared times, sorry, plus, we're on Pythagorean theorem, plus 16 squared 1280. So our C2 is 1280. We know we're not done, right? Because if we look at this triangle, 32, 16, and 1280, that doesn't even work. But what we have to do is find the square root of 1280. So C equals square root of 1280, or C equals square root 1280, 35.8. That makes a lot more sense. 35.8. So that means we can come back to our image. This side is 35.8. That means we can finish out this 35.8 plus pi again, because now we're measuring that bottom circle, 3.414 times the radius squared. So we have filled in the whole formula for this. Sorry, I didn't make that a 3.14. Now we're just going to type that entire thing into our calculator. So 3.14 times 16 times 35.8 equals, I'm going to equal it out so I don't screw it up, just to keep notes for me, plus 3.14, now we're measuring that bottom, times 16 squared, get out of exponent mode, 2602.4. So the surface area, 2602.4 square feet. And again, they'll do the square feet for you. So this is the thing with cones. If they give you the height, like right here, they give you the height, for the formula, you need the side. You need this angled piece. And since they only give you a height, you have to use the Pythagorean theorem to find the third side of this particular triangle. That will give you this. Pi is good to go. Radius, they're either going to give you the radius, which they do here, or they're going to give you a diameter, and you just cut it in half. And then side. So if they only give you the height, you have to figure out the side. If they give you the side, no problem. No harm, no foul. And then the bottom, the round portion, is pi times radius squared. Add those two together, and you get a big old number, because this is a ginormous pyramid. Or cone. Cone, it's not a pyramid, it's a cone. But it's a big one. So does that make sense that you may have to use yet an extra piece? It's annoying. Super, super annoying. All right, let's try a cylinder. Now, again, we're dealing with circles, right? And this is assuming, oh, we didn't do volume on that pyramid. Let's do volume. Sorry. Backtracking. So the volume of a pyramid is 1/3 big B, which is a little bit different than base, like for a triangle, times height. The nice thing is they kind of give you a reminder here. It's a terrible reminder. A little p is a perimeter. Big B is the area of the base. So we have to find the area first. That means we need to find the area of this circle. So we're going to start with that. Area of a circle is pi r squared. And I'm going to do this separately, even though we figured it out up there. So big B equals area of base. And our volume formula is, where'd it go? Where'd it go? Pyramid. 1/3 big B, which is area of base times the height. So now we're going to find the area of that circle, and the area of a circle is pi times radius squared. So that is, it's not a hard calculation. It's just a lot to do. So it's kind of annoying. So 3.14 times the radius squared is 803.8. So 803.8. That's our big B. So now we can do the formula. It's 1/3 times the 803.8 area of that base times the height. This time we can use the height. And this is volume. So we just type all that in, clear that. 1 down, 3, arrow out, times 803.8 times 32. 8573.87 or 0.9. They will tell you how many places to carry. They'll either say go to the nearest 10th or the nearest 100th, or maybe even the nearest 1,000th. I'm just going to go to the nearest 10th. I'm going to make that a 9, 8573.9. So 8573.9. So two very different things. And cones aren't necessarily super fun because you've got a 2-part formula. You use the entire thing. If you also have to measure the bottom as a solid, if they gave you something like a snow cone cup, you would eliminate this part because that is only measuring the bottom. Then you go to volume and you've got the big B, and the big B is the area of the base. So you find the area of that circle and then do the volume formula, 1/3 times big B times height. So you just kind of have to keep track of things. It's not that they're super hard, but it's a lot to keep track of. And that's not fun. You're already under stress. You're already under a time constraint, and they want you to pay attention to detail. It's not great. All right, let's take a look at cylinders. The surface area of a cylinder is a long one, 2 times pi times the radius times the height, plus 2 times pi times the radius squared. And there goes my voice. Let's write this one down. So 2 times pi times the radius times the height plus. You can guess what this part is. All right, there's a couple ways they can mess with you with cylinders. This is the measurement of one of the circles, pi r squared. 2 pi r squared means they're looking at this as a complete solid. Hard top, hard bottom. I got to take a drink. So if they gave you a cup that didn't have a top, you'd get rid of the two. And you do this and that portion. If they gave you a paper towel tube where it's open on both ends, you'd get rid of all of that. And you just use that. Hopefully that makes sense. It takes some, you need to do them a couple times before you feel really comfortable. But again, this whole formula is measuring everything as a solid. Solid top, solid bottom, solid middle, or sides, it's a circle or a tube. And then, then you have to alter this depending on what they give you. All right, so let's do this one because the numbers are smaller. So we're going to do 2 times 3.14 times the radius. They gave us a diameter. So our radius is 6 times 6 times the height is 18.6. And we're going to type that into, and right now, I did not do that part yet. Right now, I'm only measuring the tube portion. And that's going to be 2 times 3.14 times 6 times 18.6. So currently, the tube portion is 700.8. Now we're going to do this. This is the top and the bottom circle. So we've got 2 times pi, 3.14, times 6 squared. This is measuring both circles. Clear that looks blurry. 2 times 3.14 times 6 squared. 226.08. Add those together, you've got 8, 8, 6, 2, 9. So surface area is 926.9. Does that make sense with the solid top, solid bottom? So this is solid top, solid bottom. This would be like a cup where the top is open and the bottom is solid. Then you'd get rid of it completely if it was like a paper towel tube. So hopefully that makes sense. Let's try volume of a cylinder. Oh, not bad. This is a much better one. Pi times radius squared times height. So volume is pi times radius squared times height. And that's going to be 3.14 times the radius is 6 squared. Get out of exponent mode, times the height, 18.6. For this particular shape, volume is reasonable. All right, and don't look for a correlation between the two. So surface area, if you were going to paint this cylinder, that's what you're measuring, is everything on the outside. Volume, if you were going to fill it with water, that's what you're measuring, is the amount of water. What do you think? Another shape that required 2 different things. Super fun, huh? All right, let's do a pyramid. Yahaha. So surface area of a pyramid is 1/2 times perimeter times side plus big B. Now that is a formula, right? It's got all the little tricky ones all in one formula. So we've got 1/2 times the perimeter, and they're talking about the perimeter of the bottom, times the side plus, where'd it go? Where'd it go? Oh, plus B, plus big B. All right. And they try to give you the notes. I don't think they do a good job, but the P is perimeter of the base. Big B is the area of the base. I wish they had written this better because it seems like it might be both, but it's not. So perimeter is the outline of whatever the base is. Big B is the area of whatever that base is. All right, so let me grab a piece of paper because this is going to be another longish one. All right, we have got 1/2, that's just part of the formula, the perimeter. So we've got a square happening here. 3 plus 3 plus 3 plus 3. Our perimeter is going to be 12. You're just adding up the sides to find a perimeter. And then side, oh, they give us a side. We don't have to do the Pythagorean theorem. 11 inches. So that's the first part of our formula. Then we add the area of the base. It's a square. And to find the area of a square, it's side times side. So 3 times 3 is 9. So it looks more complicated than it is. I think that cylinders and cones can be more vexing because you might have to use a Pythagorean theorem. You could potentially have to use a Pythagorean theorem on a pyramid if they gave you the height and not the side, because you need the side. So let's do this on the calculator. We've got fraction 1/2 times 12 times 11 plus 9. That should come out to 75. That would be 75 inches squared. And again, GED will do those for you. You don't have to worry about it. Let's see if we can do the volume of a pyramid based on this. This page happens to be surface area, but we can probably do volume. 1/3 big B times height. We can totally do. Oh, we're going to have to do the Pythagorean theorem to find the volume. Yes, we are. So volume is 1/3 big B times the height. We already have the 1/3. That's just part of the formula. We already have the big B, right? Because we already figured that out. But now we need the height. So we've got this triangle right here. We know that the long side is 11. The bottom is 1.5, because if this whole side is 3, that triangle that goes to the center is going to be 1.5 on the bottom. We need to find this side. So Pythagorean theorem, a squared plus b squared equals c squared. We know the long side. The long side is 11. That's C. We know the bottom. This is midway. So this piece from midway to end is half of the whole side. It's 1.5. 1.5 squared. And we're looking for a squared. All right. So this goes back to algebraic equations. First, I'm going to figure out the square numbers. 1.5 squared is 2.25. And 11 squared, I think, is 132. Oh, 121. Yeah. Brilliant. And then a squared. That's what we're looking for. All right. So back to algebraic equations. We got to get rid of this 2.25. So we're going to take it away. That means we're going to take it away from this side. And I'm going to use my calculator. I should be able to do that in my head, but I'm just not gonna. So this is gone. Leaves us a squared equals 118.75. We got to get rid of the square because we just want a. So a is going to equal square root. And we're going to let the calculator deal with that. Green button, square root, 118.75, enter, is 10.9. That makes far more sense when you look at the measurements. We had 11, 1.5, and 10.9. All right, now we can finish our volume because our height is 10.9. So it's complicated. The calculations are not necessarily difficult, but it's a lot for you to keep track of, which is never fun, right? It's like, just give me a square and tell me to find the area and I'm good. But they don't do that. Times 9 times 10.9. So our volume is 32.7.
First meeting of the day makes it late.
Interesting. You think? 32.7 is the volume. It's a lot. And you've got your calculator, which is good. You just have to keep track. I mean, this is a lot. This is one problem. That's one pyramid. That's a lot of writing for one problem. So just know you're probably going to get something like that. Anytime you've got something with a triangle, if you need the measurement of the side, which they did give us here, you're probably pretty good to go until you get to something that says, oh, we need the height. They never give you the height and the side. They should, but they don't because they want you to work for it. But the thing is, anytime you need a third side of a triangle, just use the Pythagorean theorem and you'll be okay. You'll get it. It's just, keeping things in order. It's a little more work, but it's doable. You're not going to get shapes like this. That's a hexagon pyramid. You're going to get the four-sided pyramids. So don't worry about these guys. It's good practice. And I think the answers are on the back. Yeah. So try them because it's not bad extra practice, but these are the ones that you need to be. Oh, look at that. That's a three-sided. So you do the exact same thing. You're going to find the area of the triangle and the perimeter of the triangle rather than the square. Same exact thing. Now, what else did I bring you? Composites. These are composites. Oh, where's my sphere page? I brought you spheres. Where is it? We need to do spheres. Hold on a second. We absolutely have to do spheres. Shoot, did I not send you spheres? Okay, if I didn't send them to you, I will, because you need spheres. Balls. Let's do this one. We're going to find the surface area of the sphere and of the box, and then we'll add them together. Because really what we're doing is we're painting this shape. So we're not going to get up under the circle, are we, if we're painting it? So it's something to think about. All right, let's find the surface area of a sphere is 4 times pi times r squared. So sphere is 4 times pi times the radius squared. And of course, the rectangular prism or the box is just 2 length times width plus 2 length times height plus 2 width times height. 777, it's a nice square box. It's going to be 2 times 7 times 7 plus 2 times 7 times 7, oops, plus 2 times 7 times 7. That's going to be 14 times 7 is, or 49 times 2 is going to be what, 96? Oops, that's on my phone, not my calculator. This calculator works better. Times 7 times 7. It's going to be 98 plus 98 plus 98. I'm going to cheat and do it quicker. 294. So our surface area of the box is 298. Now we're going to deal with that sphere. Here's the thing about spheres. The 4 assumes, so 4 times pi times r squared assumes a ball. Can I make this look like a ball? Not really. But assume that's a ball. Whole thing. That's the 4. If you had half a sphere with a solid bottom, you would change it to 3. Is it 3? Oh man, I just had a brain freeze. I think it's 3 pi r squared. That includes the bottom as a solid. I'm a terrible drawer, sorry. So that would be half a ball, but with a solid bottom. And then for this one, we're not measuring anything below. We're just measuring the surface area. So we could do this and cut it in half because we're not measuring the bottom. So that would basically be 2 times pi times radius squared. And that's when you just have, what is that? Half a dome? I guess it's a dome, right? Domes are, you don't measure the ground, you just measure the surface area of the dome. So full ball, half a ball, or a dome. Let's say a dome with base, so a solid base. And this one is just the dome, no bottom, it's open. Or you're not measuring it. All right, so that's a lot, right? It's a lot. Let's jump up to and figure out our measurements. We're doing 2 pi r squared. What is our diameter? It's the length of the box. So the diameter is 7, meaning the radius is 3.5. I think that's all we need to do this. Yep. So our calculation is going to be 2 times pi times the radius is 3.5, and that is squared. let your calculator do all that. 2 times 3.14 times 3.5 squared equals 76.93. So this is 76.93. Now we're not done, right? Because we need to add the surface area of the box to the surface area of the dome. And that's going to be, I'm not even going to do it by hand, 298. Let's do that, plus 298. 374.93. So the answer is 374.93. What do you think of that? It takes a while. These are not fast. It's annoying because it can take a while. This one won't be bad. This one, again, you'll use the 2. So here's this for a full ball. For this one, because you're not even measuring the top of it, will be 2 pi radius squared. And look at the cylinder. You don't have one of the tops of the cylinder, do you? You've only got one solid on the cylinder. So a cylinder is 2 pi times radius times height, plus generally on the formula sheet, it's 2 pi r squared. However, we don't have 2 solids. We've only got the one. They forgot to draw that in. So we're going to get rid of the 2. Those are the 2 formulas you're going to use for this shape. Hopefully that makes sense. And then you add them together and you're good to go. I'm going to do this one because it can be complicated. Let's do the cone first. Let me grab another piece of paper. So the cone is pi times radius times side plus, and this is when it has a base, pi r squared. Pi r squared. And then the cylinder formula, that's a cone. Sil. Oh my God, I cannot draw. Cylinder is 2 pi times radius times height plus, if it's got bases, 2 pi r squared. All right, so we've got our formulas. What do we need? For the cone, we don't need the bottom, do we? Because we're not measuring the base of this cone. If we were going to paint it, we couldn't reach it. And for the cylinder, we're not going to measure the top. So we're going to get rid of that too. We're going to measure the one on the bottom, and they should have done a little thing there. But you have to alter the formulas, and it's not fun. It's really the last thing you want to do in the middle of a test. So do these sheets and get comfortable with it, because this is more likely what you're going to see than a nice box where they say, oh, what's the surface area of the box? They just won't be that kind. They're not. All right, let's fill this in and get it done. So the radius they give us is 6. Do we need the side? This requires Pythagorean theorem to find this side. So we're going to do Pythagorean theorem. A squared plus B squared equals C squared. We're looking for C squared. We've got 8 squared plus 6 squared equals C squared. There's A, there's B. 8 times 8 is 64. 6 times 6 is 36. That's going to be 100, isn't it? Awesome. How easy is it to find the square root of 100? If C2 equals 100, C equals the square root of that 100, C equals 10. Nice, we like the easy ones. All right, so it's pi times radius, which was 6, times the side, which is 10. Let your calculator do that because you've got that pi. 3.14 times the radius was 6 times the side was 10. 188.4. That is the surface area of the cone. Now we're going to do the cylinder. So 2 times pi times the radius, still 6, times the height. Did they give us the height? They did, 9 inches. Much easier to deal with. And then we'll have to do pi radius squared. So we'll do that whole formula. It's hard to see. That was a 6 for radius and 9 for height. So 2 times pi times the radius times the height equals plus pi again times radius was 6 squared, arrow out of that, 480.24. This one is 480.24. We've done all our calculations and measurements. Now we need to add the two together. Cone is 188.4. Cylinder is 480.24. I'm going to add the cone. And our total answer is 668.64. Whew, that was a lot. I better have gotten it right too. Oh, I don't have the answers. Shoot, I can't check my work. You guys can check my work. So what do you think? It's a lot, right? But it's doable. You just have to take a piece at a time. And then once you've got what you need, then you can add them together. Fun, fun, fun. This one is interesting. Boxes are easy, right? But you need to take away the bottom of that box when you do the full measurement. This one, here's a snow cone. Don't measure the base of the sphere. Don't measure the top of the cone. Same with this one. Don't measure the base of the cone. All right. So that's a lot. Don't let them freak you out. You'll be okay, believe it or not. Yeah, totally can do it. It's just, they do it on purpose because the more work you have to do, the more numbers you have to jot down or keep track of, the easier it is to make even a simple calculation error. And you know that that's what GED wants. They want you to make an error, get the wrong answer, not pass, take the test again. It's good. It's good for business. It's really, really good for Pearson. Not so good for you. So when you get those composite shapes, deal with one at a time, get all the information you need, deal with the second shape, get all the information you need, then just combine the two answers. So it is doable, but it does take some practice. I gave you tons of practice, and I think most of them have the answers, so you can check your work. Because there's nothing worse than going down a track and thinking you know how to do something, and then finding out that you were missing one tiny piece, so all your answers are incorrect. So check your work. All right, any questions?
Well, my understanding is that
All right, I'm gonna let you two go, and I will see you.
set up.
I think tomorrow is a regular day for language arts. I think.
I hope so.
We'll
I
let
look
you-
forward to my classes.
What's that, Tammy?
I said, I hope so. I look forward to my morning classes.
Nice. I think tomorrow is a normal day. I don't think I have a meeting.
What fits into that?
No, I should be fine tomorrow. We should do language arts tomorrow
Yes.
And where do
And
you
look-
put your videos?
on YouTube.
Okay.
And the videos here are not public on YouTube because they're for you guys. So they should be in an email. Did I forget to send you an email last week? That's possible.
Yeah.
I've forgotten before.
And
I
that
get going and then it's
tells
like,
us where they're at or whatnot, or how to get to them.
I may make them public now so you can just go to them and get what you need. I think that's probably the easiest.
Yeah.
So go to my channel, Robyn MacKillop, YouTube / Robyn MacKillop.
I don't know, but I've got a few of your videos saved, so if I go to one, it'll help me find it.
Yes. Yeah, you'll be able to get back to my page. And I'll make those all public this morning. That way you can go back and get whatever you need and skip whatever you don't need.
Okay.
But it's doable. It's just kind of a pain. I don't like problems that take you 5 minutes to do. It's too long. It's
Yeah.
too easy to just make one slight error and the whole thing is, you know what I mean? It's like,
Yeah.
just give me a square and let me find the area.
Uh-huh.
All right. So I will see you all tomorrow for language arts.
Yeah.
And have fun with this math because it's worth doing.
Have a good night.
You too.
Bye.
Bye, everyone.